thoughts? What are you thinking when you see this problem? Okay, yeah.
This is like picking what the U value is gonna be is probably something that I struggle with the most.
Sure.
So I guess probably with this, I would probably pick like 1 plus x and to the 1/3.
Yeah, that's it.
Okay.
But if this was the wrong U value, you will be able to instantly tell when you find the derivative.
Okay.
And I'll show you how you can tell just by finding the derivative. So what's our derivative?
Give 2/3.
Mm-hmm.
Okay.
Now, what gives you assurance that you're on the right track just by looking at this? Yeah, you see that? So that's a good sign, right? If you see it, if as soon as you find your derivative, look back at your problem. If you find some sort of a match, then you're on the right track. Okay. Okay, it's not where it needs to be yet. We still need to go through and rearrange, but at least we see that 2/3. That's a good sign.
So you move the exponent?
Mhm.
And did you take out the 1/3?
No, I made it as one fraction. I put that x down to the denominator. I made it share the same space as the 3. Because I don't have to worry about pushing out anything until after I get my integral set up. Oh, were you already here?
Yeah. Yes, I'm right there.
Okay, yes. Then cancel the x out, then push the 3 out. That's right.
Yeah. Oh, okay. How is the 3 not 1/3? Like, how did you turn it into 3? Like, just 3?
Because I cross multiply. I mean, it was 1/3. And then when I cross multiply it, it ends up being in the numerator here. Because it's,
I see. Okay.
but it was, it's 1/3 times 1 times x to the 2/3, which is, I just merged it together to be one fraction.
Then you cancel the x to the 2/3.
Yeah.
And then when do you take out the 1/3 or like the 3?
I would take it out now.
Okay.
Because now I'm just trying to see if I can make this look like a rule that I want to use.
Okay. So then you use the 1/u.
Mm-hmm.
Okay. Which is L in.
Yeah, natural log absolute value of u.
Okay. I just did one like number 2,
Okay.
when like I was doing it my 7th.
Mhm.
And I didn't know, like I was doing page 1, example 3, and it's like, once I got to the third example, like I found I could really decide what I wanted to do as my U value.
Which page?
The first page, the very first one. Like I was redoing similar to.
Page 9, the one we just did today.
No, no, no,
Oh, first page.
the third example.
Oh, no, yeah, this we can't do, or I didn't teach us how to do this. This is long division, so we're not gonna do that one.
Okay, okay.
Yeah, so we only can do one, which is if it's like x to the first power. If it's x squared, this is long division, but I just haven't seen it on the AP exams, so we're just not even gonna do long division. Yeah.
So.
So this one, yeah, I changed it because this would be long division, and this one is synthetic. Yeah.
Okay. What did you change?
I made the denominator x plus 2 instead of x squared plus 2.
And then for synthetic division, you're
Yeah, take the opposite sign. You set the denominator to go to 0.
okay. So then it would be like 1, and then we would have to do a bunch of zeros.
Yep.
And you take down the 1, right?
Mhm.
And then your first exponent is x to the third, whatever.
We start off with x to the 4th, but we're dividing by x, so our degree will fall by 1.
Okay.
And everything after that will just keep going down by 1.
Okay.
Yeah, make sure that we haven't done any calculus yet.
So on this one, do we do a u value?
Mm-mm. The nice thing, well, there is use substitution, but how many, you see how these are all individual terms?
Yeah.
We can treat them like individual problems.
Okay.
So the first few, I can just rely on what? Yeah, and the last term is a little bit of use substitution.
So for the last part, oh, I see what you did.
Mhm.
What did you do? The 10 integral 1/u, how did you get that?
I just pushed that 10 out in front.
Oh, so you just kept it separate.
Mhm.
Okay.
To make it easier to identify what rule we're looking at with that 10 out of the way.
You always add plus C?
Yes. If there are no bounds, I need to have a plus C at the end.
Will you give us one move bounds?
Yes. Yeah, we did some today in class. The back page, you'll see some bounds.
Do we need to simplify like the 4x to the 2 over?
You can, but I won't take off points if you don't. No, it's fine. Take your time.
And then for this third one,
Mm-hmm.
would your u value be secant x?
More than that.
So secant x minus 1.
Yeah. Yeah.
Okay.
What's derivative?
Secant x tangent x.
Yes. And as soon as you're here, you should be able to have a pretty good idea whether you're on the right track or not.
Okay.
And how do you know? Yeah. Yeah. So if you're not sure about this step, about your U value, as soon as you're here, you should feel either more confident or less confident about whether your U value is correct.
Okay. For the next one, did you just break it apart?
Yep. Good. Only one term below. The nice thing about breaking it apart is now I can just think of it as 3 independent problems and it's not one messy problem.
Can you subtract it down?
Yeah. So what does this clean up to be?
To the x.
Yeah.
And 2, right?
Yeah.
Just whatever e to the x.
Yes, but what do we need to do to get this to look more like a rule that we want to use?
Bring enough system.
Yeah. So we got 3 rules, 3 terms here. We got to decide what rule do we want to use for each of these.
I mean,
yeah, e to the u rule. So here's what e to the u rule looks like. So do we have to go through u substitution if it looks this similar? No. So e to the x is just what? Just e to the x. Yeah.
What about the plus c?
We'll do that at the end. There's more than one term here, but we'll just do a plus c once at the end.
Do you
I mean, yes, you're technically having plus 3c, but 3c is the same thing as a constant. Because if I do 3 times the constant, it's still a constant, so I don't have to do 3c. Does that make sense? Just it's just all kind of piled up into just a single term.
Okay.
Okay, what's next? Mm-hmm.
So it's 2x.
Mm-hmm.
And the next one is e to the negative x.
This one, we gotta be more careful. This is not just an x, so I would actually spend the time to go through u substitution for this one.
Oh.
Otherwise, we're gonna lose track of what's gonna come out of it, so. So what could be our u value?
Negative x.
Mm-hmm.
Wait, so why can't you do that? Why do you have to do u substitution?
Because the negative x is not just an x, right? Anything that's more complicated than x, I got to go through u substitution. Because there's going to be something left over out of this that we're not seeing right now.
E to the second.
E to the second, that's just a number. So e to the second would actually be power rule.
Okay.
But if it's anything that matches, if it's anything more complicated than e to the x, then we want to go through u substitution. Unless you can see what that leftover is, but it's easier to convince ourselves what it is. So if we go to u substitution, we're really just going to see, oh, it's a -1 that's left over. And that -1 will just carry over to the end, and e to the u is e to the u. But yeah, so that's why we go through u substitution. Otherwise, we may forget that there's a -1 that's going to be that's going to have to be kept track as part of our answer.
So you added another integral.
Yeah, I added, I didn't have to, but visually it's just a reminder that, okay, this is a independent problem here. I'm just going to pretend like it's its own thing and go through that process. You don't have to do that if you don't want to, just maybe visually it's easier if you just see all the familiar things around it. Mm-hmm.
I think I'll have to redo this one.
Sure.
So you ignore the bounds, right?
Yeah.
And then. They do use substitution.
Yeah.
For x to the second.
Mm.
Yeah.
Mm-mm.
For x.
Mm-mm. Remember, u is never just x, right? It's always more than just an x. 3 over x.
Why wouldn't it be?
Because the derivative of x squared will be 2x, right? And there's no way 2x can handle this x because it's up in the exponent. Like, even if the x was produced, we can't just cancel an exponent x with an x at the level, right? So that's not going to be a good fit.
Okay.
I know this feels real weird because you're looking at that 3 over x, you're saying, how is this going to do anything to help me with the x squared? But notice the x is in the denominator, so when we go through derivative, it may do something different than what we expect. It's not 3x, right? It's 3 over x. But let's see what that can do. So if I want to find the derivative of 3 over x, how would you rewrite it? Yes. Yeah, you bring it up first and then go through power rule. That's right. And then what gives you assurance that even at this stage that you're going down the right path? Yeah, that -2. It's not quite where it needs to be, but this can turn into x squared, and that should match up nicely with that x squared down there. Right? What's the rule for e to the u? Yeah, just without the plus c, since we know the bounds are coming.
So it's just. So then after that, you do. Like, are you ready to round after that?
Close. Anything we need to do before the bounds?
Oh, yeah, sub the 3 over x.
Yeah.
Thank you.
Yeah, you can skip number 6 and 8. These are not good fit for our quiz.
Okay.
But tonight, if you can try 7 and 9, that would be good. Number 9 is a little tricky. You got to bring that 2 up before you can do A to the U rule. Just be aware of that. And then I'll do morning review tomorrow morning.
Bring the 2 up before you do it?
Yeah, because I don't have a rule for A to the U in the denominator. I only have a rule for A to the U in the numerator. So.
And then, tomorrow for the morning review, which one are you doing?
I'm doing the one after it. So it's the morning quiz review page. There it is, page 13. Yeah.
So if I were to come like to your first block, because I don't have a first block, would you mark me present for our block?
Yeah, I can do that.
Okay. I don't know if I could do that, but I think I could try to make that work.
Okay, well, we can try that, see how it feels.